My name is Mikołaj Gąbka, and as you heard, I'm studying biomedical engineering at AGH University of Science and Technology. Currently, I'm the participant of InnoFood project aimed at creating fully automated aquaponic system. It can be helpful in exospheric agriculture, but I will talk about it later. And I'm also involved in the cultivation of plants in extraterrestrial conditions in the context of my engineering thesis work. So let's move to the presentation. First of all, I want to make a short introduction to understand the problem. The process of discovering and creating new inventions is relatively simple. We are defining the problem as precisely as we can. Then we conduct theoretical research. We are making thousands of mistakes, thousands of failures, and then we find the solution. But no matter how good the solution may be, they are never final. Over time, they become outdated and no longer applicable. So the loop closes, and once again, we have to find the problem. The most simple example is the wheel. Wheel was invented almost 6,000 years ago, and till this time, we are making new advancements. We developed the wheel because the first problem was only to transport heavy weights. Now we want to make the fastest cars, so the problem is the same, but more advanced. And why am I talking about this? You probably don't know this man. This is John Boyd Dunlop. And when during 1888, John was in Belfast. He was looking at his son who was riding a bike. And during this time, the bike of his son had very hard tires, very hard wheels. So the boy was jumping and jumping and jumping. His father decided to help. He took a simple pump. He pulled the air into gum, and the bike stopped moving. Why this is important? Because it became apparent the pneumatic tire, which works pretty well nowadays. So, moving to the point, I want to tell about the problem that we are trying to manage. This is similar to the problem I was talking about. I had to start with agriculture 0.0, so the first stage of agriculture in the history. During this stage, the beginning of this is called agricultural, not 0.1, but 0.0, because there was nothing. This is the first step. In fact, we were only using horses to move heavy wooden stuff. Of course, after some times, almost 2000 years, but yes, we created some more advanced stuff, some mechanical. We started using engines, electronical engines. I don't want to waste time on this, so I will move very quickly. Of course, the second stage was using organic and non-organic elements to upgrade the product chain. The agriculture 2.0 entered another phase of development, marked by the application of biotechnology advances, and the introduction of new plant varieties coupled with abundant fertilizations. The first stage was precision and sustainable. It is the definition, the simplest definition. We were starting using satellites to control the mechanical stuff. And then we moved to smart farming. So we have everything in the phone. We got alarms. We can see the oxygen, the temperature, the humidity level. What is the next step? In our opinion, the next step wouldn't be taken on the Earth, but on the, for example, Mars. How we can do this? How we can grow plants in exospheric agricultures? We cannot even discuss colonization, settlement on other planets without considering the cultivation of plants. And to realize this step, we must draw conclusions from every previous step. So even with this step with the horses, why? Because the biology, our development is the best lesson, how to do something which will not work for the year, but for example, for the thousands of years. So we defined our obstacles. We know that we have to take care of oxygen, water, ammonium, and we come up on the possible solution. The idea is pretty simple. I think that all of you saw little ecosystems, little forest closed in the glasses. This is pure biology. We are not adding anything. We are just putting some seeds, water, and then we have this is called bottle forest. Of course, this is done on a very small scale, and we want to do this on the huge scale. But there is a way. The way is aquaponic system, which is almost the closed loop. We are doing this nowadays on the Earth. We are not very forward to end the system, but there are we defined basic steps. So we feed the container with fish. We are taking the products like ammonium and putting these products in the fertilizers. We use simple bacteria. Then we are putting all of the stuff for plants. Plants converted all of stuff, for example, to oxygen, and we are returning the oxygen and pure water to the fishes. Of course, this is. I see the comment. Thank you for this comment. Yeah, hydroponic was our first idea, but we wanted to improve this with fishes. So we can try to close the loop. It would be more efficient in our opinion. We have chosen tilapias. They are commonly used in the water agricultures. They react pretty good for small amounts of light, for example. We defined the food that we want to grow: tomatoes, trees, basil. We considered root system and how the plants react to the bad environmental conditions. Then we have chosen the bacteria. Of course, we have two basic products, fish products. We have ammonium and ammonia. But we don't have to look forward to some complex solutions, because like always we can find the answer in the forests, in the Earth ecosystems. We can just use nitrification bacteria for ammonium and nitrification bacteria, Nitrobacter for ammonia. Those are pretty common, and we can convert all the not pollution, but all the bad stuff for plants for nitrate, which is converted by plants to products that we can return to the water for fish. After that, after making full theoretical concept, we make easy diagram. We will use sensors. We will use, of course, CPU, power relays for pumps, aerators, heaters, and light emitters. The difference is that we want to control this. So we want to make a closed loop, but as well we want to control this. So we need, of course, this is the the first of the first prototypes, 3D models. Sorry for the quality of the photos. We decided to make double pots, so we can put our food, our seeds in something like agar gel, which is really easy to prepare, to be prepared. And of course, the second layer is to prevent water damage for the roots, for example, for basil. As you can see, we were testing some sensors. We were connecting them in analog astronauts training centers in Rzepiennik. We are considering the various sensors like oxygen, water hardness sensor, of course, nitrates, light. I didn't include them, but we also want to use phosphor sensors. Of course, we have to think about the oxygens, so aerator, and we want to do something special. We want to use infrared light. We want to do some experiments with infrared light because we had read that it can positively affect the food, the weight and the number of food. And the conclusions are quite simple. With this product, we will save energy. We can close the cycle, so we just simply don't have to add anything from outside. It's time saving because the owner doesn't have to take care of this. It's just a normal forest, but in the chamber. This is our goal. The simplest way to tell this is we want to make the forest, but in controlled environment. So I have only one bibliography because the stages of which I was talking about was from the book Agrotronic Systems from Adam Ekielski and Karol Wesołowski. Thank you very much for attention.